about pH meters, because pH meters, each pH meter is essentially an electrochemical device, and it's really acting as a voltmeter. Meaning you measure a potential, and then there's an equation inside your pH meter that turns it into the pH. And we're going to give an example of how a pH meter could work. This is pretty close, but it leaves out some details that we can't cover in this class. But we're going to be doing a reaction that has as our oxidation half reaction taking hydrogen gas and turning it into 2 hydrogen ions plus 2 electrons. And the standard cell potential or standard oxidation potential is 0 volts for this. This is on our list. And then we're going to do one that's not on our list that you're using for homework and exams, but it is on the list, the bigger list that is in Libre texts or in the TRO textbook. And it says Mercury1 Chloride, which will be solid, plus 2 electrons goes to mercury liquid plus 2 chloride ions. And the reduction potential of this is 0.27 volts. And both of these involve 2 electrons, so we can straight add them, and of course then just add their potentials. Crossing out our electrons, we get hydrogen plus Mercury1 Chloride goes to hydrogen ions, 2 of them, plus 2 mercury liquids, plus 2 chloride ions. With a standard cell potential of 0.27 volts. Okay. And now what we're going to do is we're going to show you how the cell potential relates to the concentration of hydrogen ions. And we know that the concentration of hydrogen ions is related to the pH. So let's go ahead and do that. So I'll start by writing the Nernst equation. And now let's personalize it. So we know that this is 0.27, although we won't put that in here yet. Let's go ahead and write our expression for Q. Q is going to be, well, we have a liquid there, but we have hydrogen ion concentration squared. We have chloride ion concentration squared. And here's something new. We have a hydrogen gas, and because Q is related to the and the cell potential is related to each material in its relative state, this will be partial pressure of hydrogen. So we're going to plug that in. Although we're going to make some assumptions to simplify it here. We're going to assume that our concentration of chloride is 1, so that this term cancels out. We're going to assume that our partial pressure of hydrogen is 1 atmosphere, and that leaves us just hydrogen ion squared here. And let's go ahead and put that in. So E cell equals E naught cell, the standard cell potential, times the RT over NF times natural logarithm of the concentration of hydrogen ion squared. And we can go ahead and plug some things. Well, let's not plug that in, but we'll plug in RT here. We'll actually move this over to the other side. So the difference between the measured cell potential and the standard cell potential will be on the left. And this will be, well, R 8.314 joules per mole Kelvin, 298 Kelvin, 2 electrons, because there's 2 electrons canceled out, and 96,485 coulombs per mole electrons. So that's the term here. Then, because pH is in terms of logarithms, and because this is in a natural logarithm, we are going to write, so, well, let's bring the 2 down to the front, and so there's that 2. And then we're going to convert natural logarithm of H plus into 2.303 log of H plus. So 2.303 log H plus. Sorry about squinching it in there. Okay, so now we're getting close because we have a log of H plus. We've got all these terms in here. And now let's multiply all this together and leave us with log H plus. And, yep, so E cell minus E not cell equals minus 8.314 times 298 times, well, let's just cancel our 2's out. 2.303 divided by 96,485. I get 0.059 log concentration of H plus. And what we're now going to do is we know that pH equals minus log H plus. So the minus and the log part, we can sub in pH. And solving for pH by itself, we're going to divide through both sides. Well, yeah. And we're actually going to take and get, so 1 divided by 0.059, we get pH, well, let's just leave it how it is. E minus E cell over 0.059. And the way a pH meter works is you tell it what the standard cell potential is, you measure using a voltmeter apparatus, so measure as a voltmeter the actual potential you're measuring, do a mathematical transformation, and what you can see is that there's a direct relationship between what you measure on a voltmeter and pH. That is an idea of how you can measure pH basically by using a fancy voltmeter. And it's a little more complicated than this because we made an assumption about the gases here, but more advanced study will allow us to talk about how to avoid issues like this.